Okay, so as we look at 2-4, let's just go through, before we do regular polynomial long division, let's go through a regular division problem. You need to correct something up here, though. So students will be able to not decide, but factor. There's several typos on this. That would be Mr. Boots and not me, but I'm very thankful that I didn't have to write them. All right, so regular long division. Let's just review. You want to see how much 23 will go into 35 in this case? So once. Then we take that 1 and we multiply it to everything that's out in front. So 1 times 23 is 23. Then you'll hear me say this often in polynomial long division. Draw your line and change your signs, because we subtract next, right? So 35 minus 23 is what? 12. Then what do you do?
Drop down to 2.
Drop down your next term. So our next term is a 2, so I drop it down. So now I'm seeing how many times 23 will go into 122. What do you propose? 5. 5 sounds good. 5 times 3 is 15, carry the 1. 5 times 2 is 10, plus the 1 is 11. So then draw your line, change the sign. What is 122 minus 115? 7. Then, drop down next term, which in this case is a 6. Start all over again. So 23 goes in there 3 times. 3 times 23 is 69. Draw your line. Change your signs. What do you have left over? 7. Bring down one last term. So we end up with 77. And then 23 goes into 77, I'm going to guess. 3 times. That's another 69. Draw your line. Change your signs, and what do you have left over? 8. What is that 8 called? That is your remainder. Now, you're big boys and girls. You've been taught to add a decimal point and several zeros and keep going until you have its decimal equivalency, right? You can determine whether it repeats or doesn't. Well, we're not going to do that in polynomial long division. We go all the way back to 3rd grade when you started division. Didn't you put like a R8 here, a remainder 8? Well, really what we do with a remainder, if this remainder in this case is positive, we are going to add the remainder. If the remainder were a negative 8, we would subtract the remainder. So whatever the sign of the remainder is determines on whether you're adding or subtracting it to the quotient up top. And then you're going to take that remainder, in this case 8, and you will divide it by whatever you divide it by out in front. So the proper answer is 1,533 plus 8/23. That's the exact answer.
So if it was negative 8, you do minus.
You would do minus 8 over
Right.
Okay, so that's going to be a regular division. The reason why we do that is polynomial long division is very similar. So we're going to write the steps out for polynomial long division. You have to make sure that all placeholders are accounted for, by the way. So look underneath here. We start with the next cube, that's your highest degree term, and you go 3, 2, 1, 0. So no terms are missing. If there are missing terms, you have to add in place values of 0, x to the whatever. So I don't have that there. So my very first step, we're going to take and look at just the first term. So I'm going to only look at the 3x and only look at the 3x cubed. So the first term outside and the first term underneath. So you're going to divide out the first terms. I highly suggest you do that off to the side. Less in your head, more on paper, kill a tree. Always take what's underneath, 3x cubed, and divide it by what's outside. You can kind of remember that because what's outside always goes underneath anyway. Can I not warn you people?
I just didn't care.
You just didn't care.
No.
Grab a. Okay. So when I divide that out, what do I have? X squared. X squared. That's what goes up top. Because our whole goal is to get determine what do I have to multiply this first term here by, in this case 3x, what do I have to multiply it by to make it look exactly like that first term? We want them to be identical. The best way to do that is to divide them out. So if I take an x squared and multiply it to 3x, I do get 3x cubed. But our second step is to take our answer there, so we're going to multiply, just like we multiplied in the regular long division. We're going to multiply the divisor, which is your outside, this whole outside, the 3x plus 2, that's your divisor. We're going to multiply the divisor by the result of step 1. I'm having you write down the steps so you don't go home and forget. So I'm not just multiplying the x squared with a 3x, I'm multiplying, distributing it to everything outside. So I also have to multiply it to the 2. So I get x squared times 3x, 3x cubed, they should be, that's a 3. They should be identical, number for number, variable for variable, x1 over x1, and they are. So you don't want one to be a positive and one to be a negative, not yet. And then don't forget to multiply the x squared to the 2 as well, so plus 2x squared. You should have like terms lining up. If your like terms don't line up, you've done something wrong. So, third step, you're going to hear me say this a lot, draw your line and change your signs.
Wait, I don't get where the 2x.
Because we have to multiply the x squared to everything out in front. So we also have to multiply it to the 2. So if you have a binomial out here, you'll always have a binomial down here. Trinomial out here, you have a trinomial. Alright, so then we're going to draw our line. Change all signs. Not just the first term, but all signs. So because they're both positive, they both change to a negative. And then 100% of the time, these should now be opposite signs. So the whole goal is for them to cancel out. So then your fourth step is to just add down, just like we did before. So your first term should always cancel. A 5x squared and negative 2x squared, subtract to keep the sign larger, you get a positive 3x squared. Then what did we do in long division after we added down? We brought down the next term. So my next term here is the 8x, so I'm going to bring down a positive 8x. And so we need to add that at step 5. Bring down the next term. And then it just starts all over again. You just keep repeating those 5 steps. So we have a new problem. So I'm going to look at the first terms. This time my first term underneath is the 3x squared. The outside first term always stays the same. So off this side, I'm going to take what's underneath, 3x squared, and divide it by what's outside, 3x. What do I get? Just an x. So that x goes up top here, plus x because it's positive. Then we need to multiply that x to everything out here. Just like I multiplied this one to everything, we're going to multiply the x to the 3x and to the 2. So x times 3x is 3x squared. These should look identical, and they are. And x times 2 is a positive 2x. Like terms are lining up. It's a good thing. Draw your line. Change all your signs. So my positives become negatives. My first term should cancel, which they do. And then just add down. So I've got 8x and a negative 2x. Subtract. Keep this on a larger. So I get a positive 6x. Now what?
That's it.
Yeah, not 7. So I get a plus 7. And we start all over again. My first term underneath is a 6x. My first term outside is still a 3x. So I'm going to take the underneath 6x, divide it by the 3x, and I get what? Just 2. So it's positive, so a plus 2 gets brought up top. And I have to multiply that 2 to everything that's out in front. So 2 times 3x is a 6x, and a 2 times 2 is a 4. Draw your line, change your signs, and it's just a coincidence that everything's positive and I just keep changing to a negative. If you had a negative, you change it to a positive. Your first term should cancel out. What do I have left? A positive 3. What's that? That's my remainder. So how do I put my remainder up here? It's positive, so we have plus, the remainder is 3, and you divide it by everything that's outside, not just the 3x, but everything that's outside. 3x is plus 2. So this is your entire answer. That's your quotient. So obviously, because we have a remainder, 3x plus 2 does not divide evenly into the polynomial, therefore it is not a factor of the polynomial. If it were a factor of the polynomial, we would have no remainder here. Questions on polynomial long division? Okay, so let's do another one. This is just written in a different form. The problem when it's written in this form is you have trouble figuring out, well, which one goes underneath the division bar and which one is outside. So look at it this way. You have a 1-car garage. That's your division bar. This is the first car because it comes first. This is the second car. How do you determine which car goes in the garage? If you had 2 people living at your house and one of them is not your parents, it's like, I don't know, your best friend. And you have a 1-car garage. You're both out working, going to school, whatever it is. Who gets to park in the garage? Whoever, I know, the most expensive car. Well, I'm pretty sure that your friend with the Yugo, you don't know what a Yugo is, do you? That's because it's a terrible car. Your friend with the Yugo still loves his car. He wants to park in the garage too because he doesn't like having to go outside when it's raining to get in his car. Not that it rains all that often here in Phoenix, but still. So who gets to decide who gets to park in the garage? Whoever gets there first. I will grant you that the most expensive car typically should go in the garage. But this is the car that comes first. Its car gets parked inside. But look at what you start with and what you end with. Are we missing any values? You're missing an x squared and x, so we have to add placeholders. So we have a 2x to the 4th minus the x cubed. We must add in plus a 0x squared plus a 0x. And then finally minus 2. So we have 2 placeholders. We may or may not need them, but we need them in order for like terms to line up. It's possible that they may be superfluous, there's your word for the day, extra, but you never know. You put them in there just in case. Then on the outside, we've got 2x squared plus x plus 1. That gets parked on the outside. So the whole process that we outlined above, that 5-step process, we're going to start. So always start with your first terms. Just the 2x squared and just the 2x to the 4th. I don't care about anything else. So off the side, I would be dividing those. What goes underneath is what's up top, and what's outside is what's in the top. So what do you get when you divide those out? Just an x squared. So the x squared goes up top here. What do I do with that? Multiply the divisor, that's your outside, by the result of step 1. This is the result of step 1. You have to multiply it, distribute it to all 3 pieces out there. So if we have a trinomial out here, you should have a trinomial under here after you multiply. So x squared times 2x squared does indeed give us 2x to the 4th. They should be identical. X squared times x is a positive x cubed. X squared times 1 is a positive x squared. If we had not put that placeholder in there, then you would have had a minus 2 up top. And so it should be a huge clue that if your like terms don't line up, you've done something wrong. So then don't forget, draw your line, change your signs, negative, negative, negative. All of them get their signs changed. You can't add down until you draw your line and change your signs. 100% of the time, those first terms should cancel out. These are not opposite signs. They don't cancel out. You have a negative 1 plus a negative 1 gives you a negative 2 x cubed. When you add like terms, the variable string does not change. And then a 0x squared minus an x squared is a negative x squared. Then what do you do? Bring down that next term. So I have to bring down the 0x. Then it starts all over again. So our first terms are the negative 2x cubed and the 2x squared. So negative 2x cubed divided by positive 2x squared. What do I get? The negative 2 and 2 does indeed give you a negative and then x. So now we finally have a negative product, or I'm sorry, quotient. So we're going to put a negative x up top. Be careful with your signs. We're going to multiply that negative x to everything out in front. So negative x times 2x squared gives you a negative 2x cubed. They are identical and they should be. Then negative x times x is a negative x squared. It's just a coincidence that those are identical. And then negative x times 1 is a negative x. Draw your line. Change all your signs. This time all the negatives are being changed to positives. My 2x cubes cancel. These are opposite signs. They also cancel. And all I have left is just an x. Bring down that last term, minus 2. So my first term is an x and a 2x squared. Look what happens when I take the x and divide it by the 2x squared. What do I end up getting? The x cancels downstairs, so don't you get a 1 over 2x? You don't want a fraction. If you get a fraction, we're done. This then becomes, this whole thing here becomes my remainder. So you can have a polynomial as a remainder. I'm going to make the assumption that remainder is positive because the x is positive, so I'm going to put a plus here. I'm going to take that remainder as is, x minus 2, and I'm going to divide it by everything that's out in front. 2x squared plus x plus 1. So this entire answer right here, including remainder, is your quotient. Question on polynomial longitude. It's very easy to get messed up in. You've got to practice, practice, practice. So do not just guess and check on your math exam. All right, so then let's look at synthetic division. You're going to write some rules for that, just in case you forgot. Different teachers will do it slightly differently as far as how it's set up and how the work is shown. If you're consistently getting the correct answer, you can use a different method, that's fine. I don't care. But here's what you're going to do. You've got to look for placeholders. So here's my polynomial, and I'm going to divide it using synthetic division by a binomial. Typically, I will only use synthetic division. Well, I'll only use synthetic division with a binomial. And your coefficient of your x needs to be 1. It's not 1. I'm not going to give that to you on a test because it becomes more complicated. This ends up being a fraction. So if I had, 3x minus 2, I have to convert that so that this coefficient is 1. So you have to divide everything by 3. So I might give one of those to you. Let's see. But I won't give it to you until I talk about it. All right, so I have a 3, a 2, a 1, a 0. I'm not missing anything. If I was, I'd have to put in those placeholders also. So the very first step, step 1, you're going to write down only the coefficients of the long polynomial. Synthetic division is a shorthand version of long division, polynomial long division. So I'm going to write down my 6 and save some space, negative 19, 16, negative 4. Then I like to draw an L, leaving space here for some numbers to be written. And then I'll put a vertical line here after this first number because whatever goes in this box will end up being the remainder. And I like to put what I call a shelf over here. That's the part where teachers can be different. So, step 2, this is what I'm dividing by, this x minus 2. So remember, whatever's inside parentheses is always the opposite sign. So I'm not putting a negative 2 on the shelf, because the shelf tells us in the synthetic division what we're dividing by. I'm going to put a positive 2 here, because if, I usually use synthetic division to find zeros. And so if this were a 0, wouldn't the 0 here for x be 2? If you set that equal to 0 and solve, wouldn't x be 2? True or false? Okay. So I'm really dividing out by 2, not a negative 2. And inside parentheses, always opposite sign. So write yourself that note. Place the opposite. Sign of, and I'm going to call this x minus h, whatever that binomial is, onto, and our technical word is the shelf. Whatever the opposite sign is. Again, noting that the x in that binomial should have a coefficient of 1. So then step 3, you're going to drop down the first number. So I always, you'll see me always putting an arrow there in that space, and you're going to drop down that first number below the line. It's important that you know to drop it below the line, Jordan. Right? Then our fourth step is going to be to multiply what's on the shelf to what's below the line. So multiply the shelf to the number below the line. Place this value in the next space. Bless you, above the line. I'm trying to be as detailed as possible so that when you go home and you get confused, you go, oh, okay, that's right. This is the next space above the line. So we're going to multiply 2 times 6 is 12. That 12 goes in that space that's available above the line. Then similar to long division, your fifth step is to just add down. And so we're going to add down and place that value below the line. So in this case, I get a negative 7. Then the process starts all over again, but it only starts, you just repeat steps 4 and 5 over and over again until you finish. You don't have to repeat the whole process. So I'm going to multiply what's outside or what's below the line to the shelf. So 2 times negative 7 is negative 14. Add down. I get positive 2. Shelf to below the line, 2 times 4, or 2 times 2 is positive 4. Add down, I get 0. This 0 is my remainder. Because 0 is my remainder, 2 things occur, 2 things I know. Since 0 is my remainder, therefore, since the remainder is 0, x minus 2, that's what I divided by, that's my binomial, is a factor of the polynomial, and x equals 2 is a 0 of the polynomial. So I know 2 things. If my remainder becomes 0, what I divided by, that binomial x minus 2, is a factor of the polynomial because it went in there evenly. And solve that binomial for 0, set it equal to, or solve it for x, set it equal to 0. X equals 2 is 0. So I know that this graph of this polynomial is going to cross the x-axis, or at least touch the x-axis at x equals 2. So what is my answer? My answer to this problem, take what's to the left of that vertical bar right here and write it. These are your coefficients. I started with an x cubed. So this becomes x squared, x, and a constant. And then this would be your remainder if there was one. So my answer is 6x squared minus 7x plus 2, that 2 is positive. So when I divide the polynomial, this polynomial by x minus 2, I should get a result of 6x squared minus 7x plus 2. And because it's a quadratic, if I could factor it, I would. Questions on that before we do the last piece, the last problem? Is that ringing a bell? Okay. The last problem, you have to put in placeholders. So I've got to the fourth, to the third, I'm missing 0x squared, x, and then my constant. So when I write down my numbers, my coefficients, I've got 1, negative 10, 0, I want to put that in red, 0, negative 2, and then 4. You draw your L, your vertical line below 4, and then your shelf. What am I putting on my shelf? Yep, opposite sign, so negative 3. Bring down that first number, 1. Process starts all over. So I've got negative 3 times 1, negative 3, add down, negative 13. Negative 3 times negative 13 is positive 39, add down, negative 39. Negative 3 times 39 is negative 117. Add down, get negative 119. Negative 3 times negative 119 is 357. Add down, we do get a remainder this time of 361. So, here's how we're going to write it. I start with an x to the 4, so this is x cubed, x squared, x, and that's constant. So my answer will look like x cubed minus 13x squared plus 39x minus 119. My remainder is positive, so I'm going to add the remainder of 361. What did I divide by? X plus 3. So that is your quotient. Now that tells you that x plus 3 is not a factor of the polynomial, and x equals negative 3 is not a 0. The graph does not touch across the x-axis at that point. We will finish the rest of this tomorrow.